When it comes to our sun, we still have no idea what's going on out there. We know that there are other stars in the universe that have more than one sun, but here in this solar system, it's just us and our star. Join with us to explore the universe, learn about its wonders, and search for life beyond Earth. However, these two stars wouldn't have been as close together as our current Sun and Earth are. Instead, the distance between the two stars would have been similar to the distance between Earth and Jupiter. Scientists think that this object must have exploded apart. But why? If the Sun had a partner star, that could have been enough excitement for this hypothetical dwarf planet to break itself apart. According to lead author Dr. Nader Hagibapour, who is based at the Quai d'Azur Observatory in France, the gravitational perturbations caused by the passage of the second star would have destabilized the orbits of objects in the asteroid belt and triggered giant impacts. It's completely off the charts. But wait, there's more. Of course, all of this is just speculation for now. We don't know that the Sun had a twin star, but there is some evidence to support the theory. And this is not the first time that astronomers have hypothesized that the Sun might have had a sibling. Scientists have also been able to estimate the mass of the so-called protoplanetary disk that this hypothetical twin star would have orbited. Maybe there are actually two answers. One of them is yes. The fact that the Sun might have had a twin makes sense to me. And I'm not the only one. A recent survey of more than 3,000 stars found that nearly half of them have at least one companion star. So it looks like our Sun might have had a friend after all. If you think about it, the odds of our solar system forming with only one star are pretty low. As technology improves and telescopes become more powerful, we resort to learn more about the origins of our solar system and the possibility of life elsewhere in the cosmos. Remember to stay tuned for more updates. And as always, thank you for watching. Who knows what we might find out there? But one thing is for sure, the universe never ceases to amaze. Stars come in groups. They form in clusters, and it seems unlikely that our Sun would have been a lone wolf. The main difference between that hypothesis and the hypothesis put forward in the new paper is that the researchers in 2011 thought that the second star would have orbited very close to the Sun. According to the model proposed by Dr. Hagibapour and his colleagues, the two stars would have been relatively far apart. And guess what? It turns out that the disk of dust, gas, and debris left over from the formation of the planets would have been almost twice as massive as the Earth. If it is, then it could be anywhere in the galaxy. If it's out there, it may be watching us. Then if it is, then it probably has a lot of questions. Questions like, whatever happened to my buddy? Or what did I miss? But seriously, the existence of a second star in the early solar system could explain a lot of things about our planetary system, including the asteroid belt and the distribution of certain elements in the meteorites. The researchers estimated this by looking at the structure of the asteroid belt and modeling how the gravitational interactions between the asteroids provided clues about their history. Now let's talk about that hypothetical lost twin of the Sun. What kind of star would it have been? For example, they say that the asteroid belt would have become even more chaotic. The twin star had been orbiting closer to the Sun, but the team thinks that further research will bear out their hypothesis. They aren't sure what the second star would have looked like, but they do think that it would have been similar to our Sun in terms of mass and composition. Well, because the size of a star depends on its mass, astronomers can use the mass of the Sun to estimate the size of this second star. The good news is that they already have an idea of what it would look like. Right now, it's just me and you. But if the Sun had a brother, then he'd be out there with us too. The Gaia mission is tasked with mapping the positions and movements of every star in our galaxy. The data collected by Gaia allowed astronomers to determine the mass of the Sun using a technique known as stellar seismology. Stellar seismology is a method of measuring the internal properties of a star by studying its oscillations. By measuring how a star wobbles and shimmers, scientists can determine its physical properties, including its mass. A new paper published in the journal Astronomy and Astrophysics suggests that the Sun may have had a companion star. if the Sun were bigger. Then it would have had a greater gravitational pull, and therefore the orbits of the planets would be larger. Given what we know now about the structure of the solar system, astronomers are able to work backwards to estimate the original size of the Sun. Using this knowledge, they were able to determine that the second star would have had a mass equal to the current mass of the Sun. So this lost twin would have been a star very similar in size and composition to our own. A co-star of equal mass that would have been ejected from the solar system when the protoplanetary disk around them was only 600 million years old. That would have been 4.4 billion years ago. Or is it? Well, according to a new study, the Sun may have had a twin brother at one point, but it may have been ejected from the solar system over 600 million years ago. This meteorite is a Uranite, which is a type of meteorite that comes from the asteroid belt. The authors explain that Uranites are stony meteorites that contain almost no iron and magnesium. They say that the chemical makeup of Uranites makes them different from other meteorites in that they seem to have formed from material that condensed directly from a cooling gas cloud. In short, they're pretty unique. And this lost twin could be watching us right now. It's not science fiction. Keep watching to find out what evidence scientists have for this wild theory. You won't want to miss this. Welcome to our channel, where we bring you the most exciting adventures in the cosmos. This means that for at least some time early in the history of our solar system, we would have had two suns. To back up this hypothesis, they also looked at the distribution of certain elements in the meteorite collection at the Northwest Africa 2701. But here's where things get interesting. Uranites are believed to have come from a dwarf planet or something bigger that existed in the asteroid belt. He went on to explain that this provided the energy needed to cause major restructuring events in the asteroid belt and probably in the whole System C in 2016. The Gaia mission performed an analysis of over 2 million stars in the region of the Milky Way called the Oort cloud. In short, the Gaia mission gave scientists a much better understanding of our Sun, and it showed that our star is actually a bit smaller than expected. Dr. Hagibapur said, "It's hard to describe just how big such an event would have been." According to Dr. Hagibapur, it's possible that the material from this disk went on to form some of the smaller bodies in the asteroid belt, including the asteroids and meteoroids. Back in 2011, another team of researchers claimed that observations of the asteroid belt suggested that the Sun may have had a co-star. The authors of the new paper acknowledged that there are some aspects of the model that need to be improved. One thing that remains to be seen is whether or not this hypothetical twin star is still out there somewhere. And if scientists can find any evidence to support the hypothesis, then maybe we can finally answer the question of whether or not we're alone in the universe. I don't know about you, but I tend to think that the universe doesn't really work that way. It's just one of the many mysteries of the universe that we're slowly beginning to understand. We hope you enjoyed learning about the latest findings related to the Sun and the search for life beyond Earth.